Hello and welcome to a new episode. This time I'm taking a trip to the scrapyard, looking for random items that I deem either too useful, too interesting, or too valuable for the trash. I will then try to repair them or at least do a teardown to learn something about how they work. So let's have a short walk around here then and see what we can find. Over here, collected in old bathtubs, we see old electric motors and parts of those. Here in the front, 3-phase induction motors, not bad parts, but at the moment I'm more interested in gear motors. And here in the back, old starter motors and some washing machine motors. And this old Metabo power drill here is the first item that I will take with me. You can find a lot of old power tools here, but most of them have already been stripped for parts. This oldie looks pretty good though. This container here is filled with ATX power supplies, but I guess I have more than enough of those already. But it's still good to know where I could find them in the future. And next to massive steel parts, we find everything from wrecked cars over forklifts to lawnmowers. And over here, I find some favorites of mine, old welding machines. This machine is a 250 amps DC TIG welder manufactured by the German company Lorch. Top-notch machines, but unfortunately the electronic controls are damaged beyond reasonable repair. This often happens after stuff has been brought here because it is handled without any care at the scrapyard. The second machine is a 360 amps water-cooled DC TIG inverter by the German company Dalex. Dalex does no longer make TIG and MIG welders. Today the company is focusing on resistance welding equipment. But back in the day, they made absolutely first-class TIG welders, and I'm very tempted to take this thing home. And here we have a gear motor, and it has relatively little rust, which means it hasn't been here too long, and this is the second item that I will keep. We find really a lot of industrial leftovers here. Parts you never see in normal life, and here and there entire machines are buried under tons of steel. And here are more motors and power tools. And this rare machine here is a vacuum pump by the German company Leibold. The third item I will take with me. And over here I spotted a heavy-duty pneumatic piston by Festool, another keeper. And another vacuum pump. Will take that with me as well. I've taken a good look around here and I really have to force myself not to buy way too much scrap. That might only end up wasting too much space around my shop. And I certainly have a weakness for huge heavy equipment, and there is a lot of that around here. Look at this huge enclosure, for example. I first thought it was another welder, but it turns out to be a power supply for an 18,000 watt xenon lamp. And I really gotta say that I would like to build an art installation with this gigantic cogwheel here. Man, what a rare find, but I think it's just too heavy. So let's start then to take a closer look at the items I bought, and let's try to get them running again. I start with the power drill, and the first thing I do is to look for damages on the power cord itself. After no major damage could be found, I'm starting to open the enclosure of the drill. Here we find a filter component. This one contains 3 capacitors, and these components often burst, causing old power tools to malfunction. This one, even though it has a date code from 1973, is looking just fine. Moving on to the motor brushes. They as well look just fine, and they still have good contact with the commutator. After this visual inspection, I dare to plug it in and use a piece of abrasive fabric, in German Schleifvlies, to remove the rust from the chuck. And we're already at the point where we can test the drill using the old drill bit that came with it. The power drill itself seems to work just fine, but it loses the drill bit continually. The old chuck seems to be worn out. I now ordered a brand new replacement chuck, but then learned that old Metabo drills had smaller shafts than most modern machines, and the chuck didn't fit. But then I found another used Metabo chuck on eBay for just a few bucks and installed it on the machine. It's now back in action. It's not as good as a brand new high quality hammer drill, of course, but the drill itself cost me less than €5. On to the next item then, the gear motor. It was sold by a company called Garrock, and they appear to be from Cologne, you know, my city. And you might wonder why it has these weird attachments, and I wasn't sure myself what exactly it had been used for before yesterday when I saw exactly this kind of motor installed at a gate when doing grocery shopping in the neighborhood. This appears to be the exact same system, and it is obviously used to open and close roll-up doors and gates. And via two plastic chain wheels, electric end stops are coupled to the shaft of the gear motor, so that the motor will stop turning once the gate is fully opened or fully closed. The nameplate tells us that this is a 740 watts, slow turning, 3-phase induction motor with a gearbox reducing 1370 minute to the -1, that's the SI unit for what you might call RPM over there, down to only 32 minutes to the -1 or RPM, but at an enormous torque of 125 Newton meters. That's roughly 92 foot-pounds. And for many applications, low speed at high torque is actually much more useful than the other way around. And since I'm not planning to use this for a roll-up door, I remove the end stops, chain wheels, and the on-off switch. Now I open the enclosure to get to the electrical connections of the motor. And this is pretty much the standard configuration that you will find in 3-phase motors, at least here in Germany. 6 terminals leading to the 3 stator windings. This would allow you to connect the windings either in a star point, German Sternpunkt, or delta, German Dreieck configuration, and to reverse the rotational direction of the motor. Here they are connected in a star point via these little brass pieces here. The yellow-green wire is the protective earth connected to the conductive parts of the enclosure, and the 2 white wires typically lead to an over-temperature protection switch. For a quick test, I temporarily connect the motor to a 3-phase relay, in German Schaltschutz, and now I can use an ordinary light switch to turn the motor on and off via the relay. And again, I use a piece of fabric to get the rust off the old shaft. And the next item is this massive pneumatic cylinder manufactured by Festool. I've never owned anything like this, and I'm really excited about this find. I start by disassembling it because I want to look inside and potentially remove rust that might otherwise damage the seal if not removed. I loosen the bolts and carefully push the piston out the cylinder with a mallet. And unfortunately, rusty water is coming my way, telling me that the cylinder has been out there at the scrapyard for a while. One lesson I already learned: when picking up stuff from the scrapyard, try to buy those things that have just come in rather than those that have been lying there for a while. I carefully remove all the surface rust again with abrasive fabric and also some WD-40 until the surfaces are all smooth again. This has turned out to be a great method if you only want to remove what is absolutely necessary. I also apply new grease to the piston, hoping that it is the right type and will not damage the seal over time. After putting the cylinder back together, I exchange the old hose barbs, in German Schlauchtüllen, by new quick-release connectors and apply some pressure to test the cylinder. It has a very short travel way of only 1 centimeter or so, but it can apply enormous forces. And I'm already working on a system to control the pistons with a microcontroller, and I'm thinking about building some kind of pneumatic power hammer with it, maybe for the forge. And here's another completely different object that I found at the scrapyard, buried under a pile of random trash. A Super Nintendo, and in case you've never seen that, yes, that's what the European version of the SNES looks like. I paid 40 euros for the 6 items I retrieved from the scrapyard that day, and I paid them by weight. The SNES has hence probably cost less than 1 euro, so let's give it a shot. I start by cleaning it from the outside, as I almost always do when finding things I really like. The next step is opening the enclosure to look into the insides. For that, one requires an actual Nintendo screwdriver, which I happen to have since my GameCube has the same type of screws. And I used the compressor to clean the Super Nintendo from the inside. I also took a look at the electronics, but couldn't find any obvious damages. Since it didn't come with an AC adapter, I had to use my multimeter to find out the correct polarity of the power jack. Then I remembered that Super Nintendos have an internal rectifier and are usually supplied with AC. And since they have their own rectifier, you can also power them with DC without being in danger to choose a wrong polarity. The SNES has 3 jacks on the backside. The left one is for audio-video and either RGB or composite, and it's the same one the GameCube uses. The one in the middle is the output of a UHF ultra high frequency modulator, and you can connect that to the antenna inputs of old TVs, as I explained in my video online with my 1980 TV set. The right one is the power jack. So I ordered a third-party controller and a cheap game cartridge and connected the SNES to a lab power supply. So, I hope that you liked this video, and if so, please give it a like if you want to see more. I have already put some work into those vacuum pumps, and I also bought the Daleks welder, but those are very big projects and they deserve a video of their own. So if you want to see that, like this video. A German version will also be uploaded over the next few days.